we'll see how to create groups and users in Linux. Now, creating groups and users is a responsibility of the system administrator. The system administrator would normally facilitate the process of creating groups and the users for all those users who need access to the system, which means that in the lab, if you try to execute these commands for creating groups and users as a normal user, it wouldn't work. So you need to have some elevated privileges on the system, and that means you need to log in as a root going forward. So you should be root user, only then you could try these commands. More on that at a later time, but let's understand in a general how it is being done. Groups allow users with similar job roles to be grouped together for ease of administration. So why we typically create groups? This is for ease of administration. So if I have say 20 users who are working in my organization as clerks, then there are couple of them as Unix admin, couple of them as DBAs, then I can create suitable groups and assign them. Moreover, files or directories have permissions for the owner, for the group members. So it helps me in the entire user management process if I could club them together into groups. Obviously, those users who are doing the same job role are clubbed together into a named group. To add a new group to the system, if you do not have a group created earlier, you can say group add -g followed by the group ID. Now this whole thing is optional, meaning if I do not provide the group ID will be automatically decided by Linux. You just have to mention the name of the group to be added. Each group has two identifiers, GID, which is a numeric group ID and would be unique throughout your system. So whichever Linux system I am talking about, no two groups would have the same GID. Then there is a group name, which is a text name, which is again unique. So obviously as an end user we are worried about group name, but when it comes to keeping a track of what is the group ownership of the file, Unix does not mention the group name, it only talks about group IDs. But when it comes to displaying to the end user, group IDs will never be displayed, it will simply display the name of the groups. But internally what it tracks the GID of a file or a directory to determine the group ownership of that particular file or directory. When you create a group this way, all the groups are stored in the file etc group, and this file itself has a specific format as such. So let's try to add a demo group if it is not already there on the system. So there isn't a demo group as of now. So I am adding by saying group add. I told you that numeric GID is optional. So I am adding a group called as demo grp. Now if you see, the details of it got added into etc group. I am checking the last line of etc group now. It shows demo grp, then there is something called as X, which is a placeholder, password placeholder, then there is a numeric GID, and the last field seems to be blank. So understand what is the structure of that etc group file. The columns, various fields, are separated with a colon. The first field is the group name. The second field indicates encrypted group password, if any. So what we do, it would hold a group password. So groups can also be password protected, and if that is the case, the second field would store the encrypted group's password. The third field is the numeric GID. If while creating the group, if this was specified by the person creating that group, then that group ID will be picked up. If it was not specified, Unix will automatically derive it. User names having this group as the secondary group is the last field. So to which people on your system, to which users on the system, this particular group acts as their secondary group. Names of all such users as a comma separated list would appear in the fourth and the last field in etc group. As of now, I just created the group. I never assigned any user secondary group as demo grp. That's why this field is blank. But later on, when we add a user, you will see, we'll come back to this line again, and you would see a comma separated list of users to whom this particular group is assigned as their secondary group. Next one is, well, that was all about group. Next one is about adding users to the system. You can add users to a Unix system using user add command. So it was group add. This one is user add. So see what's the full blown syntax of user add command. User add -u UID. Like a group has a numeric identifier GID, a user has a numeric identifier called as UID. A group has a group name. Here a user would have a username. Remember, all these parameters, the ones that I am talking about now in this highlighted section, they are all optional parameters. That's why they are enclosed in square brackets. Which means even if I do not provide a value for it, it would still pick up some value. So -u followed by the numeric user ID that you want to assign for this user. -g and then mention the name of the primary group. So what is the primary group of this user? So my user, let's say, plays a dual role as a Unix admin as well as a DBA. Then which of those two groups, Unix admin and DBA, should be assigned as a primary group to this user? I said Unix admin. So the moment my user logs in, he would be reportedly shown as a member of Unix admin group. But if he wants, he can use new grp command to switch from Unix admin group to DBA group momentarily. So -g followed by the primary group name. Obviously this group must have been created before. -G followed by comma separated secondary group names. So if this user is a member of more than one groups, then which are those secondary groups that he is a member of? It must be a comma separated list. You must provide the group names and all those groups must exist on your system. -m is to create the home directory if it is not already there. -d is to mention the path of the home directory for this user. Typically, this path is /home/username. So see what it means. If I do not mention this, it will create a directory of the type, home directory of the type /home/username. Automatically that directory will be created. But consider a case that instead of /home/username, I want to mention some other directory for this user as his home directory. Then I can mention one. Then Unix expects that the directory should already be there. Well, if that's not the case, then you are supposed to include -m. -m is to make directory. So make this directory if it is not already there. Default behavior is, it will anyways create a directory but in a default location /home/username. -e followed by a date in this format which specifies the account's expiry date. So by account's expiry I mean this account is only available until this date. People say, what would happen after this date? Will that account get deleted? Answer is no. Account will not get deleted. Account will be there, but it will be in an expired state, which means the user cannot now log into the system once that particular date has uh, approached. Hyphen C followed by comments if any, also called as GCOS information. So you are free to write anything about that user, like Tom is my Unix admin, some comment about that user. So at a later stage, when you try to find out who is Tom, there are several Toms on the system. Although usernames would be unique, UIDs would be unique, but I say Tom A, Tom B, Tom C. So I don't know which of the Toms I am talking about now. So a comment to introduce that who is this particular person, to which department he belongs to, or which is the ticket because of which this user request was raised and the account got created. So for your future reference, you can put some meaningful comment. Hyphen S followed by path to the command shell. So which shell you want to assign to this user? Remember I said during the user creation the default command shell is determined. Typically on most of the Unix it would be bin ksh. But if you want to override it, you can mention any of the other shells that you want. So after this user gets created and he logs in for the first time and subsequent times, the command shell would be the one that you mentioned during the user account creation. So you can mention the complete path of the shell /bin/bash /bin/ksh or /bin/sh or /bin/csh, or one could also mention /bin/no login. There is also one shell /sbin/no login. Now if you assign this as a shell, the user cannot log into the system. So people say, why did you created the account in the first place then if he is not supposed to log in? He cannot log in, but some other user can always run programs as that user. So I cannot log into the system as that user. So login is disabled, but I can always switch to that user account internally and I can always run a program as that user. So no login could be one of the shells that one can assign. -K followed by the skeleton directory. Typically the skeleton directory is etc/skel. So I am here. See what the skeleton directory contains. Some files by default. Now what is the purpose of a skeleton directory? Consider a case that I want to create a user account, and the moment the user account gets created, I want to copy some files to his home directory. Example, login notices, readme files, some of the help related files that I have written. So some user defined files needs to be copied to his home directory. So this is how you would have done it in 2 steps. Create the user, copy all the files from a safe location to his home directory. Instead, if you copy those files in etc scale directory, which is a skeleton directory, then the moment a new user account gets created, all those files are automatically copied. So consider a case that I have added a file called as login help. Whatever you want to write into this file, I just wrote one line. This is a login help. Then I put another file called as other notice. These are the other instructions for the user. So whatever you want to put in files or directories, you are free to copy it here in skeleton directory. So the moment a user account gets created, all these files will be copied to his home directory. If not mentioned, which is the skeleton directory, then the default skeleton directory will be etc/skel. So whatever exists in this particular folder will be copied to the user's home directory, and ultimately the name of the user. So which user ID you want to create. So this is the way to create it. So I said user add -g Unix lab. So this means the user's primary group is Unix lab. The secondary groups to which the user belongs to is DB and admins. -c followed by some comment. -s the shell to be assigned followed by the user that you want to create. So let's create one user. I would try to create it on the similar lines, except that the username would be demo USR. And let me make him member of the group that we created earlier. Secondary membership is for demo GRP as well. So the user account got created. Did I mention his home directory? No. Did I mention the skeleton directory? No. So let's go into the directory of this user and check what all files are there. See, you see login help and you see other notice.txt. Now how come these files got copied? Because they were pretty much present into the skeleton directory of that user, or the skeleton directory of my system. That's why they all got copied over to the new user's home directory. Question is, can this new user log in now? Answer is no. Before that, why he is unable to log in? Let's understand. When I create a user account, where does the user details get stored? User details are stored in the file etc passwd, and the password and the account expiry related details are stored in a file etc shadow. Let's understand the structure of etc passwd file. So let me check what's the last line of my file now. Last line is for the user that we created, demo USR. So understand the structure. This is the structure of my file. The first field is username. Username is demo USR. The second field is encrypted user password, which in this case is X, because I told you passwords are not stored here. Passwords are now stored in password, and account expiry related information is stored in etc shadow. So there is only a placeholder here saying the password encrypted does not exist here. That X indicates a placeholder, which means password is not here, it's in etc shadow. There's a reason. Earlier versions of Unix used to store encrypted passwords here in this file itself. And if I show you what are the permissions and why they moved the password now. So older versions of Unix used to store encrypted user password as the second field in etc passwd file. Nowadays, there has been a security enhancement being done. Passwords, even when they are encrypted, are no longer stored in etc passwd file. Instead, they are stored in etc shadow. Understand why. So when I look at etc passwd file, to whom is this file readable? Everyone. Owner, who is root, members of the root group, and even for that matter the file is readable by others. But when it comes to shadow, which is being owned by root, who can read this file? Only root. So if I store an encrypted password here, I might copy it from some user, because I can always check that particular file, contents of that file, because the file is readable. I might copy the username and the password in my notepad, take it back at home and use some decryption logic to see if this is the encryption, what could be the decrypted password for that user. In those days, there was a very famous software for password re-engineering, which uses a brute force attack with a dictionary of words, and then it checks, is this password in a working state? If the moment the software says yes, this combination works, that means I have found out that combination which I can try now in the office. So what people used to do, they never used to try these things at office, because if I try a brute force attack means I have a dictionary of words and I know who is the user. The user is demo user. So I will write or I will use that brute force attack software to use this username with the dictionary of words that I have. And then every time I will try demo user, some of the common passwords, welcome one, hi there, whatever. So it will try with the dictionary of those words. One probable combination is likely to work, right? I mean, it will try some randomized software, randomized passwords, and one password combination with that username might work. But what system admins do? They further to tackle this thing, they say after 3 unsuccessful logins, the account should get locked. What is the purpose? The purpose is to stop a brute force attack to crack a software. So I know that my system has a limitation. I cannot try a brute force attack on this system because after 3 unsuccessful tries, my account will get locked. So what I do in this case, I copy this whole line into the Linux system that I use at my home. Right? There I remove the limitation that password will get locked after 3 unsuccessful attempts. So I never put that restriction. Now I use the software to attack it with a brute force. So it will try some random combinations of password with this account name, and password disability after 3 unsuccessful attempts is already removed from the system. So it will keep on trying. At one point in time, one of the passwords will work. So it simply tries with random password. It might take couple of hours to couple of days depending upon the complexity of the password to crack it. But at some point in time, some combination is definitely going to work. And that the brute force attack software, when they'll reveal you what is that key combination that worked as a password. Once I know this, next day I come to the office, I log in as demo user, I know the password. This was the reason why keeping a password in etc passwd file was more harmful, because the file was globally readable. Now the moment the passwords are moved to etc shadow, I as a general user, I can't even get what is the encrypted password. So forget about copying it at home and trying a brute force attack software on it. So I do not have even the permission to read the encrypted password file etc shadow. Clear? There was a famous software then called as John the Ripper. John the Ripper is a password cracker. So it uses a brute force dictionary attack, and then it tries to crack in a software, the password rather. And then it will tell you what is the password. So now that anybody other than root cannot crack it, so it makes somewhat the systems secured. Now people say, what if root wants to do it? Obviously then root is the boss, he can do anything. And I would say, rather say, why would root do this? Because root can always switch to any other user account without being prompted for a password. So obviously root will not do this. So he is the one person whom I trust the most when it comes to Unix system. If he himself becomes the internal hacker of the system, obviously then life becomes difficult. So I told you what's the logic of storing the password in the shadow file even when it is encrypted. Well, coming back to the structure of my etc passwd file, the first field is username. The second field is encrypted password. X in that position simply means the password is not here, it is instead in etc shadow. I told you what's the reason. The third field is the numeric user ID. The fourth field is the GID of the group, which is the primary group for my user. Which is my primary group? Unix lab. So what is the GID? 504. That's what it shows here. 504 is the group ID of the primary group of that user. So GID of the primary group. Comments if any, which is the GCOS information, which in my case is this, followed by path to the home directory. I didn't mention the home directory path, so the directory got created in the default location using the default conventions, which is /home/username, followed by the path to the command shell. While creating the user, I categorically mentioned the shell should be KSH. This is how the user got created. Now question is, what about the password? Was it created in etc shadow? Let's check it out. So I said tell -1 of etc shadow. There is a user called as demo user, but see this field, second field is the encrypted password, but the encrypted password is not there because I never assigned a password to this user so far. I just created the user account, but I never assigned him the password. Let's assign him the password. Well, as of now I am giving welcome1 as the password, although it gives me saying it's based on a dictionary word. It seems to be a very simple password anybody can crack, but I still took a chance, and then I check what's there now. See, earlier the second field was having only 2 exclamations, which means password hasn't been assigned yet to this user. Now instead this is the encrypted password. Clear? So when it comes to etc shadow, this is the username field, next is the encrypted password, and the remaining fields are related to accounts expiration and password history and aging information. A quick way to check what are the other fields is to go and say man of shadow or info on etc shadow. So it will talk about what are the different fields in this one. So it will talk about what are the other fields. You could have also said man 5 shadow. So it talks about shadow encrypted password file. First is the login name, second one is the encrypted password, third field is days since January 1st 1970 that password was last changed. When was the password last changed? Next field is days before password may be changed, days after which the password must be changed, days before the password is to expire that the user is warned, the grace period, days after password expired that the account is disabled. So after password expiry, how many days you want to disable that account? Days since January 1st 1970 that the account is disabled, how long the account has been disabled, and the last field is reserved, is not being implemented as of now. So if you see, there are 8 fields in etc shadow, but out of which I am primarily interested in the first 2 fields, the one that tells you the username and the one that tells you the encrypted password. In the absence of user password, you would see exclamation exclamation, that means the user was never assigned a password for that matter. So etc passwd stores user information, etc shadow stores the encrypted password and account expiry related information, account and password related password expiry related information. Now earlier I have shown you, when we checked this information, tell -1 of etc group, there was a group called as demo grp. There was no password for this particular group. This was the group ID, and the last field was missing, which indicates, which I said is the fourth field, is the comma separated list of users to whom this group has been assigned as the secondary group. Let's check it now. Before I do that, I said demo grp, not demo grp, demo usr. So now you see demo grp is one of the secondary groups assigned to this user, and the moment I have done this, I see it here now, the fourth field. So this is the group name, this is the encrypted group password as a placeholder now, the GID of that particular group, and comma separated list of users to whom this group has been assigned as the secondary group. So this is how one can create groups and user accounts in Linux along with the file. Okay. Now given the understanding of etc group and etc passwd, there are a couple of assignments now. So I'm pausing this video. I will give you the assignments and you need to work on it. Writing pure shell scripts. So let's understand how devices work in case of Unix or Linux for that matter. Unix, unlike Windows, treats all devices as files, which is very different. So every device you attach to your Linux or a Unix machine is actually treated as a file. These device files are however different from regular user files. So it's not like I connected a printer to my machine, so that printer is now visible as if it's a file. So if I want to print something, I need to edit it and write something to it. It's not like that. I can use those files, refer them in commands, but in a different way. So you cannot edit those files. They are special device files. And there are some peculiar characteristics of those device files. Number one, they are all stored under /dev file system. So all those devices will be stored under /dev. Each file represents a device which is either of the type character special device or a block special device. So whatever device you connect to Unix, number one, a file for that particular device will be created under /dev. Then the device would either be of the type character special device or it could be a block special device. So when I go to a /dev directory and if I say ls-l, you would see the first character of those device files as either B or C. C indicates a character special device, whereas a B indicates a block special device. So for example, if I refer to a hard disk SDA, this is the first hard disk connected to my system, then hard disk is also treated as a file because it will also have some inode number. When I look at my console, a console is a character device, that's why it's reportedly shown as C. So if I go to /dev and try to list out SDA and console is a character special device file, whereas SDA, which is my first connected hard disk, is a block device. Well, apart from this, you must have noticed with respect to a regular file, say sum.txt, you see what you usually see here, the file type identification followed by read write execute permission set for the owner, group members and others, the link count, then the owner of the device or the file for that matter, root and the group name, root. Here in my case it's dick. Typically you see here in general the size of the file in bytes. Well, here there is no size in bytes. Instead you see major and minor device numbers. They are called as major and minor device number. Major number identifies the device family and minor number identifies a specific device in that family. So if I check, hard disks are from the family with a major device ID as 8. And which hard disk I am talking about from that hard disk families, because in my computer there may be several hard disks. Family would be same. Major device ID would always be 8. But the minor device ID will be unique then. So the first disk 0, second disk as 1, third disk as 2, so on and so forth. But the combination would always be unique. So remember, whereas for a regular file it shows the size of the file in bytes, for device file it instead displays major and minor device IDs, followed by the last modification timestamp. Now when I check that the last modification timestamp is showing something of today, because this device tree gets reconstructed every time you boot the system. So every time I boot, the the device files will be recreated, detected and recreated. So that's why the time is showing as of today, when the system was powered on sometime today, followed by the name of the file. In this case, instead of name of the file, I should call it as a name of the device, because every device is again treated like a file. But that doesn't mean I can edit and start writing to it. So I can't start writing directly to this. A block device, while doing input output operation, uses IO buffers. So what is the basic difference between a character special device and a block special device? The basic difference is, when you do an input output operation against a block device like a hard disk, the input output goes via IO buffer. IO buffer is the memory part where the contents are temporarily cached. Whereas a character device, while doing an input output operation, bypasses the IO buffer. So keyboard is a character device. So the moment I type in one key, it's echoed on my screen. It never says type the command first, until then I will wait for my buffer to be full, and once the buffer is full, whatever you typed will be displayed in one shot on the screen. It never happens that way, right? So keyboard is a character device, whereas hard disk, where you do the input output operation, is done in units of buffered IO. That's why they are called as block special device. A hard disk in real life can either be used as a block device, or for some special applications it can also be used as a character device. So there are some special applications like clusters. Cluster is a collection of group of machines acting as if it's one big machine. Then in case of clustering, you want to avoid all the problems related to input output, because there are multiple machines trying to write to the same shared disk. In such cases, typically we implement clusters against character devices. So the moment one machine says write, it won't be buffered, it will be directly returned to the disk. Assume the other machine says write, it will be immediately returned to the disk without buffering. So a disk in general can either be used as a block device or could be used as a character device. But if I'm eliminating from this discussion those special applications like clustered use of a disk, then most of the time a hard disk would be used as a block device. So in my case, the demo machine is not a clustered machine. So there is no appealing reason why I should use a hard disk as a character special device. So if you see in a general standalone machine, your desktop, your laptop, or a standalone server which is not part of or which is not running those special applications, typically hard disk connected to all such servers machines would act as a block device. Whereas in certain cases, like I said, in the clustered application usage case, a disk can also be converted to a character device which is shared between more than one machines, and then applications can start doing IO against that character disk device. That is to avoid caching related problems. A block device indicates a formatted disk, while a character device, also known as a raw device, indicates it's an unformatted disk device. So in one case we typically format it with some file system which is a block usage, whereas in some other case we use it as a character device, an unformatted disk. Certain applications prefer raw or character disk device because IO performance is slightly better, and forget about the IO performance, it also avoids any problems associated with local caching being done by the operating system. So consider a case that I have two computers writing to the same shared disk. Now there could be problems related to caching, because I told you no IO happens as a direct IO with a block device. So a block device would typically do two things. A block disk device typically reads ahead and prolong or postpone writes delayed. So a typical block device will have two characteristics. Number one, read ahead. Read ahead means even when somebody didn't tell me to read it, the data from the disk will be read ahead of time. But when it comes to writing, writes are often delayed. So understand this. I said read my file abc.txt which is on track 24 sectors 100 to 270. This is where my file is stored on the disk. It's on track number 24 between sectors 100 and 270. This is where my file data is actually stored. It's a tiny file. When I say read me this file, Unix will not read only from track 24 sectors number 100, 101 till 100 and 270. It will read the entire track. But my data is only between sector number 100 and 270. This is where my data is. But it will instead read the entire track. Whatever number of sectors are there on that track, it will read the complete track. This is what is understood by read ahead. So it reads anticipating. What if you need more data from the same track? Then where does this data is stored? It is stored in the input buffer. Input buffer is the memory region set aside for input output operation. When I modify this file in memory and I say save the file is not immediately written to the disk. Instead, it goes in the output buffer. Once the output buffer is full, then the buffer will be emptied onto the disk. So how does write operation happens? Writes are often delayed. Means although it appears to me like the write operation has happened, but the actual data is written only into the buffer. Once the buffer is full, then the write will actually go to the disk. The buffers will be emptied out to the disk. So read happens ahead of time even when I didn't request, and writes are often prolonged or delayed. Write never happens immediately. When you see these two characteristics in a device, disk device, then we can tell for sure that the disk is acting like a block device. When you do not read ahead of time, when writes are no longer delayed, that means the disk are acting like a character special device with no buffering. I told you earlier, a character device while doing an I/O bypasses the buffer. So raw or character device allows only one file to be stored on a device at a time. So irrespective of the disk, understand what is a raw disk. A raw disk is a disk which I never formatted. So if I never formatted, will it have a file system? No. Will it have a inode table? Since I never formatted, it will never have an inode table. It will never have a file system layout. Then is there any mechanism to determine if I store multiple files on this device, assuming it is possible? Is there any mechanism where I can say file 1 starts from this location to this location, the file 2 starts from this location to this location? Because there is no inode table, there is no tracking register itself. Now why there is no tracking register? That is because I never formatted the disk. Why I never formatted the disk? Because I wanted to use it as raw. Clear? This is because of that missing file system register or the inode table, that there is a limitation. A raw or a character device allows only one file to be stored on that device at any given point in time, because there is no tracking mechanism where one file starts and where it ends, or where the file pieces are scattered throughout the disk. There is no tracking mechanism. So consider a case that I bought a disk of 160 GB and I stored only 10 MB file on it. That's it. Remaining space is a wastage space because I cannot use it to store any other file now. This is because these disks are not formatted and thus they do not have a file system created on them. Since there is no file system, individual multiple files cannot be tracked through inode table. Files on a formatted disk device are tracked using inode table in Unix. Remember, during the initial discussion I did talk about the inode table structure. What all attribute it stores. I said there is a direct block, then there is a single indirect block, double indirect block, triple indirect block, which are nothing but linked list which points to the file pieces of a file which has been scattered while writing throughout the disk. And that is why it is still possible to retrieve those file pieces back in the same order, because there is a linked list structure which links all those file pieces together. An inode table tracks file attributes for all the files stored on a particular disk device. And now I do not have an inode table. I do not have an inode table because I never formatted the disk to create a file system layout on it. So this is why there is no inode table, there is no tracking register available now. Because of this limitation, now these files can only store, these disk devices can only store at any given point in time a single file. Each disk in Linux is uniquely identified using a device name which is of the format /dev/sda, sdb, sdc, so on and so forth. So each disk, the first disk that you connect to your machine will be named as /dev/sda. Second will be sdb. Third will be sdc, so on and so forth. So what does that dev sda sdb indicates? A physical disk device. Then if I create partitions on that device, on a given disk, if I further logically divide it into partitions, then each partition will also be separately identified in the form /dev/sda 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What does this mean? Which is the device? SDA. Which is the partition? SDA1. So the device itself is SDA. The first partition is SDA1. The second partition will be SDA2. So on up till SDA16. A device can support up to 16 partition. Not all of them are partitions. Some of them are logical DOS drives. So understand the partitioning scheme then. A disk can have maximum of 4 partitions. So a disk can be logically divided into at the max 4 partitions. A partition can be either of the type primary or extended. So the partition ka type could either be primary partition or an extended partition. A disk can have maximum of 4 primary partitions and at the max 1 extended partition. So am I contradicting myself for this statement then? I said a disk can have at the max 4 partitions. Later I am saying 4 primary partitions and 1 extended partition. Well, no, I am not contradicting. Read it like this. A disk can have at the max 4 partitions. All 4 could be primary. If you want to have primary and extended combination, then 3 of them could be primary, 1 could be extended. So total number of partitions should still not exceed 4. So people say, can I not have 2 primary and 2 extended? Answer is no. How many extended partitions a disk can have? Only 1 at the max. How many primary partitions at the max 1 can have? At the max 4. If I want to have a combination, then what is the possibility? 3 primary, 1 extended, 2 primary, 1 extended, 1 primary, 1 extended. But the total of number of partitions should still not exceed 4. Now what is the difference between a primary partition and an extended partition? An extended partition can be further sub-partitioned. Those sub-partitions are called as logical drives. So all these partitions will be called as a logical drive. when I go to the server to find out how many disks are connected, I say fdisk-l. Remember, these commands must be typed as a root. So how many disks are connected to my system? As of now, there is only one disk connected. That is /dev/sda, which is roughly of 85 GB. So it shows me disk is SDA. The size of the disk is roughly 85 GB. Now I check further what are the partitions on it. So it appears like there are 3 partitions on that disk. SDA1, SDA2, SDA3. One is of the type Linux. Second one is of the type swap. Third one is of the type Linux again. This is the starting and this is the ending cylinders. Remember, a disk is divided into concentric circular tracks, and the track on the upper surface and the lower surface is what is called as a cylinder. So if I talk about my first partition SDA1 starts at the cylinder number 1, ends at cylinder number 1530. What does it means? It means I have a disk. Both the surfaces are silvered, means both the surfaces can do read-write operation. Both places I can store data. So my first partition starts at track number 1, ends at track number 1530, both on the top surface and the bottom surface. So if I see this, it appears like it's a cylinder. Clear? So this is where this is the size of my first partition. The second partition starts where the first partition ends +1. My first partition ended at 1530. The second one started at 1531. It ends here. The third one starts where the second one ends +1. The second one ended at 1924. The third one started at 1925 till the end of the disk. Now how I know till the end of the disk? Because it shows how many cylinders are there on the disk and where my partition is ending. So is there any free space available on my disk now? Answer is no, because it's tightly being consumed from first up till 1530. Second one starts at 1531 till 1924. The third one starts at 1925 till the end of all the cylinders, because my disk has only 10,443 cylinders. So I can tell from the fdisk command whether or not there is a scope to further create partitions on the disk. So all the cylinders are consumed. So there are no more addressable locations left for a new partition if I want to create. df-h command shows all the mount points along with the disk usage. So I am saying now df-h. So it shows me SDA. It shows me SDA1 and SDA3. But it does not show me SDA2. Because SDA2 is a swap partition. Swapping is where I told you during the memory management functionality of your operating system, I told you why is the memory management required. Inactive contents are moved from memory to the disk, and once they are required back, they are again read from disk back into the memory. I told you those contents are written in a special area on disk. That special area in case of Linux is a swap partition. So inactive memory pages are written to the swap area, and once they are required back again, they are read from this particular partition on disk and reloaded into the memory RAM. Swap partitions cannot be addressed by end user commands. So you cannot refer the swap partition in the command saying copy my file to swap. It's not possible. That's why there is no mount point associated with swap. So since I cannot refer them, it's internal to the system usage, right? Anything that cannot be fitted in memory RAM is moved from RAM to the disk. This is for which a swap partition is being used. I cannot refer to that swap partition using end user command saying copy my file to swap is not possible. That's why the swap partition, which is SDA2, is not mounted. It's not mounted, so that I cannot refer to it. So since it's not mounted, I cannot refer to it. But then there is SDA1, which is mounted as root. And then there is SDA3, which is mounted as U002. This is called as a mount point. This is called as a device. So which device is mounted on which mount point can be obtained from df-h. The only exception to this rule I said is swap. Swap partition cannot be mounted because it's not meant for end user use. So df-h command shows all the mount points along with the disk usage. It shows the name of the file system or the device. It shows the size of that particular disk device partition, how much of the space is used, how much of the space is still free, what is the percentage usage, and where that particular device is mounted is what you get to see from df-h. If you are not sure where you are currently, you can say df-h dot. So my current working directory is /dev. I don't know whether /dev is here or here. Then at any given point in time, type df-h dot. Dot means show me the current mount point wherever I am in my present working directory. So it tells me that I am in a separate mount point called as dev. So I go to U002 TMP. I don't know where this directory comes from. I said pwd df-h dot. That means which partition, which disk I am on to currently? SDA. Which partition of that SDA? Third partition. Where it is mounted? It's mounted under U002. If I go to my home directory and then I say df-h dot, then the home directory is part of which file system? /dev/sda1, which is mounted as root. So this is how it will tell you what's the size, how much space is in use, how much is available, what is the percentage usage of that particular disk. Whereas df shows you all the mounted disk and the disk free. df stands for disk free. It tells you the disk usage, how much disk is free. du tells you how much space is being used by a particular directory. So df shows you what? Disk free usage by each mount point. Whereas du command tells you the disk space used by a directory, not by a mount point. So see here, I go to and try to find out what is the space consumption by a directory named home. See how much is the total space consumed by the /home directory? 28 MB. I say show me the disk space consumed by /home/disk. How much space is consumed by /home/disk? 392 KB. So du -s is for summary, h is for in a human readable format. If I don't put it this way, see what it displays. If I don't put -s, if I don't put -h, and directly I say /home/disk, see how it displays? It displays for every subdirectory what is the space consumption. So it says 8 KB, 12 KB, 4 KB, 8 KB, 12 KB, 16 KB, 4, 8, 12, 16 KB, all by these directories. Collectively 392 KB by /home/disk. So I may not be sometimes interested in these minor allocations or disk consumption units. I might be only interested in getting a gross consumption by my directory. Then in that case I can say du-s. S is for summary. So don't display me those minor disk allocations by subdirectories. Only tell me what is the one that is being consumed. Clear? But it does not tell me what is the unit. That's where I said put h to print it in a human readable format. Now it says that 192 is what? Kilometers, liters, millimeters. It's actually kilobytes. So that -h will print that output in a more human readable term. On the similar lines, if I only put -s on /home, it does not tells me anything. It's actually 28 MB. That's where I put it -h. Now it prints it to me in a more human readable converted value. Otherwise 28372 KB is what was the interpretation. But when I use -h, it displays you instead of KB, output is MB, GB and TB. So it will automatically perform the internal conversions. So du-sh followed by a directory shows the disk space consumed by the directory, this one in a human readable units, and that S I told you is for summary. If I don't put that S option, then it will also display me the usage by each of those subdirectories, which sometimes I may not be interested in. So it also shows for every file and subdirectory in it. So these are all the subdirectories. It displayed me by each subdirectory, which I am not interested. Then use -s to display a summary information of disk usage. So well, that's it for this session. We'll stop here.